In this lecture, we'll cover the concept of displacement of fringe in the double slit experiment. Let these two be the slits and the distance be d between them, and they are getting light from a common source S, so there is a coherence, there is no phase difference at the point. Let this point be A and this point be B. So if they are starting from the same phase, when they travel equal distance, this will be the central right fringe, and when they travel to some other point P with a distance say xa, the path difference becomes, if this is the angle made by point P from the point O, and let this angle with the horizontal axis be theta, we presume and assume that this angle is also theta because all the distances are very small, so this is also theta, so the path difference is d sine theta. Now this theta can be written as, now delta p I can write is the path difference, which is d sine theta, or write theta d, where sine theta is approximately equal to theta, and theta can be written as arc upon radius. We can take this as arc, so theta can be written as xa upon, if this is the distance between the slits and the screen, xa upon d into d is the path difference. So at this point, depending upon whether the path difference is the odd or even multiple of lambda by 2, there will be bright or the dark fringe. Now that is just the basic. Now let us come back to this point. Now suppose I place a slab here in front of slit 1. I place a slab. Now what will happen because of the placement of the slab is, let us consider shifting of this O fringe at the O point to new point O dash, and let this be going like this, where this is this slab between the path of A and O dash, and I can draw another point which can be P dash, or let it be at the same place as P. Now what is the path difference between BO dash and AO dash? The path difference, first see this diagram without the slab. So BO dash minus AO dash would be equal to this d sine theta dash. This is the new angle which we are forming here, d sine theta dash. This is the angle theta dash, and this is the angle theta dash. I am taking this point, not this point at the moment, so don't get confused. So now theta, as usual, theta dash is small, so we can take it as this distance. Let this distance be delta x, which is shifting of the central fringe we are seeing. Let this distance be delta x. This is the point where we are saying the path difference between AO dash and BO dash vanishes. How it vanishes we will see. Now theta dash is delta x upon d. This is the distance between the screen. So now the BO dash and AO dash without the slab, I am saying without the slab, without the slab is delta x upon d into d, because the path difference is d sine theta dash and sine theta dash is delta x upon d. Therefore this path difference BO dash minus AO dash without slab is this much. Now if we consider slab also in its path, then the distance AO dash will increase by an amount t times mu minus 1. This you have to, I am not doing this derivation, this can also be derived. Whenever a slab is placed in a path of a ray and thickness of slab is t and mu is the refractive index, then the optical path between these 2 points, say y and z, the distance between these 2 points, physical distance is same, but the optical distance will be increasing by t into mu minus 1. So same thing has happened here. So AO dash has increased. This is, I'll say, delta AO dash, the optical path which is increased. So the new optical path will be BO dash minus AO dash would be equal to, from this path difference you will subtract this, because AO dash is now becoming longer by this much. So delta x d upon d minus t times mu minus 1. So this is with slab. The path difference between the optical path difference between AO dash and BO dash. As I said, we are choosing O dash such a point that with slab there is a central right fringe there. That is the path, optical path difference vanishes here. So this is 0. So delta x d upon d is equal to t times mu minus 1. So delta x is equal to dt upon d mu minus 1. So this is the shift in the fringes, means the central fringe shifts by this much, each fringe, say a second fringe will also shift by this much, each fringe is shifting by this much. So how many fringes have shifted? How many fringes will be coming in this space, in this distance? Divide by beta. To get number of fringes, divide delta x by beta, which is the fringe width, which is d lambda upon d. So you will get the value of n is t into mu minus 1 upon lambda. This is the number of fringes shifted. I can derive this expression by another method also, and let us see how it looks like. Now in the another method, what we do is same apparatus, and we have, suppose, any point here with a distance x, and let this angle be theta. This is same as d, and this small d, and this is capital D, and this is S1 and this is S2. Let there be mth right fringe here without slab. Now this is A, this is B, and this is P. So we know the path difference BP minus AP by the same method. This is d sine theta, this is theta, is equal to d sine theta or x upon d into d. And this is equal to, suppose, m lambda. There is an mth fringe here. Now I place, this is without slab. Now if I place slab here, which will be the fringe here? In earlier it was mth, let there be nth fringe, and this is the thickness, mu is the refractive index. The new path difference becomes BP minus AP dash is the optical path, and this optical path AP dash is equal to AP plus effective increase due to the slab. This is the new optical path. So the path difference now becomes BP minus AP minus T into mu minus 1. This minus T mu minus 1 we could have straight away also subtracted, because this path difference, this path is increasing, so the difference between these two will decrease by this much amount. Let there be nth fringe here now. Now BP minus AP was equal to m lambda, so place m lambda is equal to minus T mu minus 1 is equal to n lambda. So T into mu minus 1 is equal to m minus n into lambda, or m minus n is equal to T into mu minus 1 upon lambda, which is same expression which we got here. This, the fringes which have shifted, T mu minus 1 upon lambda, same thing we are getting as the number of fringes which have shifted. So we can do by this method, and here when we have done by this method, this is the number of fringes shifted. So shift in fringes, that is distance shifted, will be n times beta, will be T into mu minus 1 upon lambda, d lambda upon d is equal to T into mu minus 1 d upon d. Same expression which we got here, delta x, and you can just compare similar expressions we got just by using two different methods, just to have more clarity on the concept of the shifting of fringe.